Welcome. So in today's video, we're going to talk about standard deviation. So first of all, the marker doesn't work. I have to fix the marker. Let's pause the video. Okay, so we're going to talk about standard deviation. So this is deviation. So this is the topic of statistics. So what is standard deviation? So it calculates the average deviation from the mean. Did you get it? The average deviation from the mean. So what do? We find x minus x bar. It means x represents each observation in your data. Okay, so from each observation you subtract the mean, and that could be positive or negative. Okay, for that reason we square it, and then we find the average of that, meaning divide by n in case of a population. Did you get it? But this is actually doesn't give you a correct value, the correct deviation. The reason is, I mean it is appropriate, but actually it does give you the deviation. This is actually correct for deviation. We do tend to find deviation like this, but I actually use the word incorrect. I said it is not correct. Actually, it is not that. Okay, it is correct. Okay, I shouldn't have used the word incorrect. Actually, it is correct. It is used for deviation, but it is termed as variance. It is termed as variance, but variance may not be comfortable for deviation sometimes. Okay, some people may not be used to it. Because actually it is the square. So what you're going to do, you're going to take the square root of that. You're going to take square root of that. Okay, so variance is again also appropriate for finding deviations and also good for finding deviations, but there's another kind of measure, descriptive measure for finding the deviation, which is the standard deviation. Did you get it? So we square it, then it's called the standard deviation. Square it is called the standard deviation, and we do it for all the observation. That's why we have to write sum of x minus x bar whole square divided by n, and the square root finds the standard deviation. So now this is the standard deviation. So what is the standard deviation? It's the square root of variance. It's the square root of variance. That's why variance is denoted by sigma squared, and standard deviation is denoted by just sigma. In case of what? In case of a population. If you have a population, you use this. Okay, if you have a population, you use this. If you have a sample, then you do not use standard deviation. Then you can maybe use SD for standard deviation if you have a sample. Okay? But in your course, you need to be, there is no any detail about population or samples. You do not need to care about population or sample. Okay, it is always about population in your book. Did you get it? But if you have population, then this is something different. If you have a sample, then it is different. So standard deviation, and for variance, you may denote by VAR, variance. In case of sample. In case of sample, you don't like that, but in population you do not like this. And in your book, it is always population. It is always population. Did you get it? In your book. Okay. Good. And so this is standard deviation, and standard deviation is the square root of the variance. Okay. And one more thing. For sample, the formula of standard deviation is a little different. So SD, this is for sample, and this is for population. So for sample, this is square root of sigma x minus x bar squared over n minus 1, and you denoted by small n to know that is a sample. For population, denoted by capital N. For population, divided by capital N. But for sample, divided by n minus 1. But again, you don't need to care about this because in your book it is only this given. Did you get it? Huh? Okay, good. Again, population and standard deviation we're going to only talk about. Okay, we also talked about sample, but from your point of view, or from your book's point of view, it's good to know both, but at this level it is only population standard deviation given. Deviation. Population standard deviation. Sigma is the square root of summation x minus x bar whole squared over capital N. Capital N is for population. Okay. So this is the formula for standard deviation. This is the formula for standard deviation. We have another formula for finding standard deviation as well. What is that? We're going to figure out that. Okay. So that is also helpful. Many of the times, this also might be lengthy sometimes, but the other one that I'm going to give you is going to be a short formula. So you're going to be deriving that. So pay attention. So how to derive it? This will be square root summation. Okay, what can I do here is this is a binomial. I can expand this binomial. Did you get it? I can expand this. So this would be x squared minus 2x times x bar, okay, plus x bar whole squared. Pretty straightforward. Divided by n. Got it? This will be this, and it'll be like, what happened to the sigma? If you square this inside, can you do this? This is when you didn't have the sigma, but if you have the sigma, can you still do the same thing? Yes, we can still do the same thing. How? It means sum up all this. Sum up. So you have x minus x bar squared computed for all the observations. Did you get it? For all the observations, and then sum them up. This also means the same thing. Compute x minus x bar squared. Isn't this the same thing? For all the observations. So still fine, you can do like this. Did you get it? And now the next thing that we're going to do is, there's a property that can distribute the sigma, that we can distribute the sigma into this. If you have something like this, then what you can do is, you can add all the x, you can add, let's say, if you're going to find this for an individual observation, then for that observation what you can do is, wait a minute, I'm sorry. If you want to find the sigma, it means not for individual observation, for all the observation. If you find this whole thing, then what you can do is, you can actually find x squared and sum all the x squareds. Sum all the x squared. Meaning this is what you can do. This is what you can do. Summation x squared. And then minus, you can find 2x x bar for all the observations. And then x bar squared for again all the observations. And at last, add them up or subtract whatever is given. Again, I'm going to repeat. What I said. You're going to find x squared for all the observations. Then you're going to find this thing that is given for again all the observations. Then you're going to find x bar squared for all the observations. And then whatever that is left, you're going to add them up. And in that way as well, it will not affect the correct answer. It won't affect your final output. Did you get it? If you do by computing all this for, individually, one by one, did you get it? If you compute this whole thing, let's say for one observation, and then another observation, then another observation, and then add up, or if you compute this for all the observations, and this for all the observations, and this for all the observations, and then add up, it will still end up with the same answer. Did you get it? It means we can distribute the sigma. We can do like this, summation x squared minus summation 2x times x bar plus summation x bar whole squared over n. It's pretty straightforward, isn't it? Till here. Now, what you're going to do next is, this will be equal to square root of, look, now I'm going to divide all this by n. So this will be summation x squared over n minus, and wait a minute, here we have 2x, 2 and x bar. These are constants, aren't they? Aren't they constants? 2 and x bar are constants here. I mean, you're going to have a single number which will be your mean. You're going to have 2 is a constant, you already know. Okay? But this is not a constant, is it? For all the observations, you have to plug in different x's. Does that make sense? Does that make sense? So, what I can do is, I can write this thing as 2x bar times summation x. So I can get the constants or transfer the constants out of the sigma sign. So what time is it? Can you tell me?
Notice.
9:30. Okay. So you can 23. Okay, pay attention. So what you can do is, you should have spoken in English. Anyways, so what you can do is, you can transfer the 2x bar outside the sigma. The reason, do you know why it is true? Do you know why it is true? If we have a constant multiply to all the observations, can you not have the constant common? Huh? It's the same thing, isn't it? You have, let's say, 2 times 4 plus 2 times 5 plus 2 times 6. Cannot have the constant and then add them up. If you have this, add them up. Then you cannot have 2 times 4 plus 5 plus 6. Of course. It means, of course, you can add them, or of course, you can add all the observations and then multiply the constant that you would have, whatever constant you have. It means I can write this as 4 plus 5 plus 6 and multiply it by 2 at the end. That's the property that you already know, already are familiar with. And this is the same property that we used here, isn't it? It means this can be further written as 2x bar then sigma x, because this can be taken as common. It is, there for all the observations. It is, okay, it is there for all the observations. And divided by n, okay? And then plus, I'm going to write here because I have run out of space. So summation, but it is inside of this, okay? Summation x bar squared over n. Okay, but wait a minute. I'm going to write this differently. I'm going to write this thing differently. Summation x bar is squared over n. How can I write it differently? Pay attention. So you have summation x bar is squared. Okay? So it means you have x bar squared. So this is a constant. And how many times do you have to add x bar? I mean, what does this thing mean? How do you compute this? Find x bar, then you square it, then again add x bar squared. Do you get what I'm saying? You have x bar, then square it, then again write x bar and then square it, and then add them up as how many times? How many times? How many times?
Yeah.
This means that x bar is there, you square it, and then you add up another x bar is squared, then another x bar is squared. And you do it till, how many times? Till n times, because you have n observations. And for all the observations you do that. Does that make sense? Do it n times. So cannot write like this, cannot write this, write this as x bar squared times n. Of course I can. Actually, but it is capital N. Okay? So this thing can be written as n times x bar squared, and then this divided by n over n. Okay? So you have the same thing, but you completely have, transformed it. Okay? So this will be equal to square root summation x bar squared over n, summation x squared over n. And then this is minus 2, look, summation x over n is what? Pay attention and tell me the answer. Summation x over n is what? I'm not going to tell you, you have to tell me. Here summation, I'm going to divide this into this. summation x over n is what?
Summation x over n.
It's the mean, x bar. It means 2 times x bar times x bar. It means x bar is squared. Isn't it? Huh? Or maybe for you, understanding that you understand the note later, I'm going to write this here. Okay? And then this will be plus the n cancel out. So you have x bar squared. So this further can be written as square root. So it's not visible now in the camera, is it? Huh? No, not that much. Pause the video. Now we can write like this is summation x squared over n minus, this will be 2 times x bar squared. Square 2 times x bar squared plus x bar squared. And now further, okay, so I should write the answer maybe here, okay, because I have run out of space. Okay, so this will be equal to summation x squared over n, and then this will be what? You have x bar squared minus 2 x bar squared minus x bar squared. Huh? And that's the formula. This is it. Summation x squared over n minus x bar squared. Or sometimes written this, this written as summation x squared over n minus, this thing is summation x over n, isn't it? And this whole squared. That makes sense? So is the same formula might be written like this or this. So you have two formula now for finding the standard deviation, which is firstly definition, which is this, and second the formula derived from the definition, which is square root of summation x squared over n minus summation x over n whole squared, or you can term this as sigma, x bar squared. But wait a minute. Some people might be saying, if I'm talking about population, then why have I written this as x bar? Why I haven't written as mu? For people watching this video. And actually, I'd like to tell you, actually this video is of Nepal's curriculum, and in Nepal everything is weird. Okay, people tend to write this wrong. In the syllabus it is given wrong. Okay, and that's why actually, yeah, I have to just write it as it is in the book. Okay, so see you in the next video.